Today we're going to learn a method of solving first-order differential equations. This method doesn't work with all differential equations, it only works with a specific class of first orders called separable. Separable differential equations. Now, what does that mean? Well, it means, let's say we have, for example, some differential equation of dy over dx is equal to some function g of x and y. And we want to take this differential equation and we want to separate it. We want to separate it into just a function of x, or I should say a function of y dy is equal to some other function of h of x dx. So we took some function made up of x's and y's, and we went ahead and we separated it into two different functions made up of only y's and only x's. So that's the goal here today, and this is separate a differential equation. Here I have the example dy over dx is equal to negative 1 over 8 e to the x. So what do we want to do here first? Well, let's see if we can separate this. Well, how can we separate this? Well, I think the first thing we can do is we can try to remove this dx from this dy. The way we can do that is by multiplying both sides by dx. Now what happens here? If we multiply this left-hand side by dx, is dx and this dx multiply just to give us 1. And over here on the right-hand side, it's just now attached to this e to the x. So we're left with dy. dy is equal to negative 1 over 8 e to the x dx. We're left with negative 1 over 8 e to the x dx on the right-hand side. From there, what we want to do is, once we're able to separate a first-order differential equation, we have indeed verified that it is separable. We'd want to integrate. We want to integrate both sides. So we want to integrate the left-hand side and want to integrate the right-hand side. Well, when we integrate dy, what do we get? Well, we're left with just y plus some constant c1. And when we integrate the right-hand side, well, what we can do is we can pull this negative 1 over 8 out, and we're just left with the integral of e to the x dx. Well, the integral of e to the x is just e to the x. So we're left with negative 1 over 8 times e to the x plus some constant c2. Now what do we do from here? Well, what we can do here is we can start to distribute this negative 1 over 8. And if I distribute that negative 1 over 8, I'm left with negative 1 over 8 e to the x plus, well, negative 1 over 8 times some constant. We have a constant times some constant. Well, what is that? That's just another constant. We can just call it c2 again, just some other constant. What you can think of is, you can think that this constant has been absorbed. It's been absorbed by this c2. The right-hand side, we're still left with y plus c1. We can go ahead and we can combine these two constants. Well, if we combine two constants, what we're left with is y plus, or what I should say. So we're going to subtract two constants. So subtract c1 over here and subtract c1 over here. This two cancel out right here. c1 minus c1 is just 0. So what we're left with is y is equal to negative 1 over 8 e to the x. c2 minus c1, a constant minus a constant is just some other constant. Call it c. And there we go. We've learned how to solve our first order differential equations through the method of separation of variables.